Okay, everybody, so what we've established with Max's experiment is that he thinks he's doing better than guessing at the coins. And here's his logic. He knows in his head that he should get them right half the time. Okay? He's figured that out. He got it right 62% of the time, which is 12% better than 50%. So here's Max's claim. I mean, I'm going to interject a little bit on his behalf because I'm going to try to measure his claim. But here's his claim. His claim is that if you put 0% down here and 100% here, and we are graphing the percent correct that he guesses, 50% is right here in the middle, and that's where we would, if we were purely guessing, we would end up there. Hopefully that makes sense. Max landed, let's see, there's 75, that means Max landed right about here. I'm going to put a little dot with an M. That's about 12%. Okay, he landed down at 62%. Okay. His claim would be 100% correct. I would actually agree with this if he had flipped coins infinitely, in other words, never stopped, and shown me that 62% is the exact percent of those infinite coin flips. Okay? Because that's the only way you can report on a percentage like that. We can report that we're going to get it right half the time when we guess because we know there are two sides to the coin. Only one of them matches the thing we're going to guess, and they're both equally likely. There's nothing to argue there. I mean, that's just simple probability. The thing about it is his head has a coin as well flipping inside of it where he's picking the side. But I can't see that coin. I can see the coin he's flipping. It's inarguable. It's like throwing a die. You know the die is six-sided. But I can't see his decision-making process in his head. So the only way that I can think to actually be able to simply report that 62% is the exact percentage is if I observed him on an infinite number of trials. But I didn't. He only showed me a very small finite number of trials, which means to me that in order for me to use that 62%, I need to put a margin of error on it. I've satisfied numbers 1 and 2 from that checklist. I got a random sample, which is Max throwing the coin 13 times. And then I got the center of that sample, which is the 8 out of 13, which is 62% that he got it right. I now have to put a margin of error on it. Now, we're going to spend a great deal of time in the back part of this course, starting Tuesday, with how do you calculate those margins of error. And so I don't want to get hung up in that right now. We're going to spend a lot of time with the mathematics of that starting on Tuesday. But just realize that that 62% has to have a margin of error. It has to have a margin of error attached to it. Now the question is, which one should we use? Okay, so let's just make some up. Suppose it's 3%. Okay, let's just suppose it's 3%. Let's suppose it's 3% for starters. So what does that mean? Okay, it means instead of saying Max gets 62% correct when he identifies heads or tails, it means we take that 3% and we add and subtract it from the 62%, which gives us what's called a confidence interval. It's a low bound and an upper bound. So if I take 62% minus 3%, I get 59%. And if I do 62% plus 3%, I get 65%. Now I want you to think about this for a second. Which one of these two answers is more probably correct? Max gets 62% identifications correct, or Max gets between 59 and 65% identifications correct? Think about that for a second. What do you think? It's got to be this one for a couple of reasons. Number one, 62% is in the middle of that. So we've got at least whatever precision we have up here, we've got down there. But we also have the stuff, the wiggle room around it, which is necessary. Because if I had Max flip that coin 13 more times, I doubt very much he would get exactly 16 out of 26. I doubt very much. I tried to get him to continue that night, but he wouldn't go for it. So the idea is that that random error that happens in sampling is partially alleviated by sticking a margin of error on these. So what that one would look like, it would look more like this. You'd have to put little tiny call them TIE fighter wings if you look at them graphically. They're going to look something like that. Now with a margin of error of 3%, I do believe that Max is doing better than guessing. If the margin of error were actually 3%, he is doing better than guessing. I'm confident of it, because that's bigger than 50%. I know what some of you are thinking. Some of you are thinking that 50% also has to have a margin of error. Technically it doesn't. If he guesses at 50%. That's a parameter value. That's what guessing is. That's what we assume when we flip a coin, that it's 50-50. We don't say it's 50-50 plus or minus 5. We say it's 50-50. So there is no margin of error on that, because that is inarguably 50%. This, however, has to have a margin of error. If it's only 3%, do you see how 50% is not in the interval? I'm pretty confident. That that means that he's doing better than guessing. Okay, now hold that thought. Suppose the margin of error is larger than 3%, and I'm going to give something away here for next week. It will be larger than 3%. With a sample size that small, the margin of error is probably something along the lines of 15% or even larger. Well, same thing mathematically. You take that 62% and you add and subtract 15% from it. If I take 15 away from 62, I think it drops below 47%. And if I take 15 plus 62, I end up with 77%. Now, first of all, we can ask the same question. Which is more precise? 62% guessing correctly, or between 47 and 77 guessing correctly? I don't think there's even a question there. It's got to be the interval, the confidence interval. This is called a lower confidence limit. This is called an upper confidence limit. Some of you are wondering why this is called confidence. I'm going to give you an English answer now, and I'm going to have you do an in-class quiz if you want, to really drive home the point of what confidence means. But confidence is a statistical measure that says how often is the interval that I create going to actually capture what I'm looking for. So let's take a step back now. Remember what we're trying to do. We're trying to figure out what percentage of the time does Max guess correctly. The sample average was 62%. But that doesn't tell us what's actually happening in his head. That tells us what's happening at one point in time. If we stopped at a different point in time, if we stopped at 8 and 12, for example, it's not 62%, it's 67%. So those are going to be off, because as he's working through his little whatever that black box in his brain is telling him to guess, heads or tails, that p hat is going to bop around. I'm sorry, I just used a phrase we haven't talked about yet. P hat is a sample percentage. P hat. We'll talk about that next week too. So the problem is that we have to alleviate that error with this margin. The wider the margin, the more confident we are that we have captured the actual true percentage. Here's the news, friends. I have no idea what the true percentage is that he guesses this correctly. I have no idea. It's kind of like, what's the true percentage he gets his Crocs on the correct feet? I got no idea. So I compare it to a number I do have an idea about, guessing. This looks like he's not guessing. This confidence interval, I am fairly confident, based on whatever confidence I achieve. Again, more of that on the quiz. But I'm confident he's not guessing here. I am not confident that he is not guessing here. And because 50% is actually in the interval. I mean, this interval says he might do worse than guessing, he might do better than guessing, or he might do guessing by itself. And that's the big idea of those intervals. Those intervals allow you to interpret the actual number of times, if you were to make these intervals, that you would catch what you're looking for. That's really all it is. That's really all it is. The idea of confidence is, how often are you going to catch the parameter you're looking for? Here's the catch, speaking of catch. If you only use 62% without a margin of error, you are 0% confident. The only way you're going to get the correct answer is if that sample average happens to land on whatever percentage is in his little brain. 0% confident. So you start making it wider. And as it gets wider, you get more confident. Now the quiz I want to have you do here momentarily is a quiz on 95% confidence. 95% confidence, which is one that you read about constantly in the news, and you're going to read about it constantly in your research papers. I don't think it's always justified to use 95% confidence. Sometimes I think you should even use higher. Sometimes you should use lower. Now some of you go, what's higher than 95? Why not just go to 100% confidence? You can do that. There's no problem with doing that. Watch this. If I want to be 100% confident, then just report, well, Max is guessing between 0 and 100% of the time. There you go. That's 100% confident. The problem is it's also 100% useless. Nobody wants that answer. Nobody wants that answer. The incredible thing is you can get 95% confident by bringing this way back in. And starting next week, we'll figure out how far in we have to go to stop at 95. 95, 99, 90, 80, all of those have stops. They have stops that measure where the confidence is. And this is all, we'll get into this next week. But what I really want to drive home is I want to drive home this point of 95% confidence. And although the quiz is only going to deal with 95, the same logic would apply for any percentage you decide to use. So when you form a confidence interval, let's just say this one is at 95% confidence. I could report I am 95% confident that Max is guessing between 47% correctly and 77% correctly. So I think you get the interval now. You get what you have to do with the interval. What I want to do next is have you do the quiz to drive home what the percentage part of the interval means. That makes sense? Hope so. If not, email me, and we'll see you in class on Tuesday. Be well.